You know what I mean? Like, are they weighted the same?
Well,
Are they weighted a little bit less, or is it something that we should know?
I think if you look at the course video for today covered this stuff here. Hold on.
Something about infinite, like 1 over x.
And where is it? Right here. An important property, right? Again, this is what happened with the last quiz, right? I said there's important limits you need to know. An important property is that if you have the limit as x goes to infinity of 1 over x to the n, where n is any power, that should be 0. All right? So that's the type of thing that I would expect. I don't think in my opinion, that doesn't require you grasping something other than just kind of memorizing something, right?
Wow, can I make this thing?
Sure. Does that answer your question? Okay. The thing is, I can approach this class 2 ways. And one way is to not even do the course videos, and then we have to talk about all this stuff every day. And it's going to seem like, if we do it that way, it's going to seem like we're going extremely fast in here. And so by doing that part at home, I don't have to go through all the concepts. That's the idea. But if nobody's watching them, then you're going to walk in here blank slate. You're not going to know what I'm talking about, and that's going to be worse for you. So I'm trying to encourage / force you to watch the videos.
I got that. It was 15 minutes of stuff I didn't know. So, you know what I mean? And then that's halfway through the video, so I didn't.
Okay. Okay. Well, then when we come in, this is where we can get clarification on those concepts. I think the quiz question was fair enough. For that. But I won't ever ask you something that requires you to extend on what I did in a course video, like extrapolate your own concepts from it. If that makes sense. All right.
So then it was 0?
It was 0.
Yeah.
Yeah. Did you guess 1?
Well, I graphed it and then freaking.
Okay.
I looked up on what you have on the board, the fix, but it's just like you can click on.
Yeah, we'll talk about it. We'll talk about it real quick here. At -3, you were not left continuous, but you were right continuous, and you're not continuous. At 0, you're continuous left and right and continuous everywhere. So you get yes, yes, yes for 0. At 2, you were left continuous, you were not right continuous, and anytime you're not left and right continuous, then you're not continuous. So that would have been left was yes, right was no, continuous was no. And then at 4, you are not left continuous, you are right continuous, you are not continuous. All right. And then the last one was 0. All right, so I handed you a sheet here. Does everyone have this? Everyone have this? If you could just grab that real quick, take a look at it. I would like on the top of this for you to write, at the very top, write limit summary. All right, I forgot to put that on there. And this is not something you are allowed to use on a test. However, it is something that you can reference the rest of the semester, because this is it. When we talk about limits in this class, these are the only types of situations we're going to see. And this is actually going to work in Cal 2 also, and Cal 3. So when you look at limits in big picture, this is this kind of everything, all right? Anytime the top left box here says, anytime you see any of these, you're going to have to do some algebra or some trick. Which of those have we talked about? 0 over 0, okay? We have done this, check, okay? We have talked about that. We have not talked about any of the others yet. Today, we are going to address this situation right here, all right? Now, each of these different situations is what we refer to as an indeterminate form, but we're going to have a specific section in the book where we talk about each of those forms, but I wanted to kind of get you to think about them today. We know 0 over 0 is a problem because you have division by 0, right? And that's not a good thing. Infinity over infinity is also a problem. A lot of people think, oh, well, if it's infinity on top and infinity on the bottom, then it's just infinity. But that's not the way it works. When we say that the top is headed towards infinity, and remember this is a limit, right? We're not saying it is infinity. We're saying it's getting bigger and bigger and bigger, and the bottom's getting bigger and bigger and bigger. What you have to determine is which one's getting bigger faster. And sometimes the top gets bigger faster. Sometimes the bottom gets bigger faster. Sometimes they have a common ratio. So we have to investigate more, which means algebra or some sort of trick. Now, 0 times infinity is another situation where we don't know what happens. Think about it this way. You have a number that's getting very small times a number that's getting very big. Who wins? Well, how small is this? So remember, when we say 0 here, and this is very important that you understand this. When I put 0 here, I'm not saying it is 0. I'm saying it's approaching 0. So please keep that in mind. In this limit, all of these things are approaching these values. So you have something that's getting really small times something that's getting really big. And so you can't tell what's going to happen. Does that make sense? Also, if you have infinity minus infinity, you got something that's getting really big, and you're subtracting something that gets really big. You don't know which one is bigger, so you don't know if it's, if this one is outweighing this one or if this one is outweighing that one. So you have to investigate further. This one's interesting. If you have not the number 1, okay, you have something that is approaching 1. So the base is approaching 1, and then the exponent is getting huge. What happens? Well, we were taught in other classes that 1 squared is 1 cubed is 1 to any power, right? Is 1, right? But we're also aware that if you make your power bigger, things get larger. So what's happening here is the base is trying to be 1. It's trying to be. It's getting close to 1, which means 1 to any power should be 1, right? But since it's not exactly 1, this infinity is trying to make it larger. So it's trying to like rip it apart, blow it up. Does that make sense? Like if you take a number that's really close to 1, like 1.01, and you raise that to the like 10 billion or something like that, that number's going to get bigger. But if this gets close enough to 1, then this shouldn't matter. So again, you have this tug of war happening, and we're going to have to figure out what happens. Each problem will be unique. Why is this an interesting situation? Anything to the 0 power should be 1, but 0 to any power should be 0. So again, the base is trying to get small and become 0, but the exponent is trying to turn the thing into a 1. So you have this battle going back and forth. How about this one? Why is that an interesting situation? Anything to the 0 should be 1, right? But infinity should get huge. So what happens? All right, it's a tug of war. So every single one of these are a tug of war, and that's why they all appear on this sheet. All right, they're all in the tug of war. And so we have to do something to them. Now there are other ones that you don't have to do so much with. And that's something like this. If you ever have a limit and the top is going to 0 and the bottom is going to a fixed number, do you see on the bottom what I say with fixed? I say here, fixed means non-zero and or bounded. Now don't worry about the bounded part yet. But when I write the word fixed in here, what I mean is that this is not going to 0. All right? So if you have the top is going to 0 and the bottom is going to, let's say, 5, the answer is what? 0. And we're done. There's nothing to do. There's no algebra. There's no trick involved at all.
And that's if it's like a number that's not a variable, right?
That's right. Okay. Yep. Now, what if you have fixed over 0 the other way around? That's the bottom left box. See the bottom left box? Well, that's going to be confusing for you to look at right now, but guess what? That is what we're going to talk about today also. So today are these two. Let me erase. We've already got this one. Check it off. We're going to talk about this situation and this situation today. All right? And we're also going to talk about this situation. So we're going to attack those 3 today. All right? Now, from the course video, there are some things that we need to make sure that we're clear on before we can proceed. And the first thing is to understand that this section is about 2 different things. All right? Today's lecture is about 2 different concepts. They're related to each other, but they're separate. all right? So today we're going to talk about, which one are we doing first? Infinite limits. And the other one is limits at infinity. And before we can start talking about infinite limits and limits at infinity, let's all just make sure we have an understanding of infinity. Are we all clear that this symbol represents infinity? And that infinity is not a number. Infinity is an idea. The idea is that we have something that's growing without bound. It's getting huge, right? But you can't fix it. You can't say, okay, stop it there, because that's not infinity. Infinity just keeps going, right? There are two types of infinity. Yes, you could say negative and positive. Yes, but that's not what I mean. There's actually two types. One is called countable. This is bonus information. This is not going to be on a test. I'm just letting you know this. The other one is called uncountable. All right. So look, I'll give you an example of a countable infinite set of numbers. Think about your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8. Right. That never ends. Right. Never ends. That's what we mean by countably infinite. If you take that set of numbers, that's a brace. 1, 2, 3. Forever, that's countably infinite, because you can walk your way through them. An uncountable set of numbers is a set of numbers that are still infinite, but you cannot move through them like you can move through these. And an example of that would be all the numbers between, just even the numbers between 0 and 1. You just go to a number line, you look at all the numbers between 0 and 1. This is an uncountably infinite set of numbers. All right? Just that's an FYI. There's two types of infinity. Wow, we didn't know that. Okay. All right, so infinite limits. Infinite limits have to do with us taking a limit, and we're going to have something goes to something. This is, remember when I did that with the sign junk? Remember that? I said, look, it doesn't really even matter what's happening here. All right? We're taking the limit of some function, and we're getting something to this effect, fixed over 0, all right? If that happens, we are dealing with an infinite limit. And we will deal with those. That's different than this, which is going to look like this, limit. And this time we're gonna let x go to either positive or negative infinity, and then of some function. That's the difference between these two. This one is just a limit, and then what we're getting out of here is fixed over 0. That makes it an infinite limit. And then over here, if you just go to infinity or negative infinity, we call these limits at infinity. Let's start with these. All right, we're going to start with these. I'm going to start with an example. And we don't need this right now. We won't need that for a while. I'll leave that right there. All right, so example. Let's do this. Take the limit as x goes to 2. Oh, let's go 3. From the right of 4 plus x over 3 minus x. Now this is the first time that we've actually had this happen, and we're going to do something with it. I think we have had something like this, and we kind of waved our hands at it, and we said we'll come back to it. Well, today's then. All right, so what happens? Try a direct substitution right now. 7 on top, and on the bottom, 0. Does everyone see that this is a fixed number? Fixed number on top, and 0 on the bottom. Does everyone see that? Okay, anytime we have fixed over 0, there's actually 4 different scenarios here, right? that it looks like in this box? But do you notice on all of those scenarios we have pluses and minuses? Do you see those little pluses and minuses? Okay, so let me try and explain what's happening here. With this right here, I have on the top is headed to 7, and the bottom is headed to 0. Let's just think about what would happen with a fraction like this. If you have a number on top 7, and you have a number on the bottom that is really small, right, headed towards 0, something like 0.00001. If you were to do this on your calculator, would this be a very, very small number or a very, very big number? It'd be a very big number, wouldn't it? That'd be a very big positive number, wouldn't it? Now, if I'm approaching 0, I could have also done negative 0.00001, right? That's really close to 0. But now if I do this, is this going to be a very large, it's a very large negative number, right? So look, approaching 0 like this, I get a very large positive number. Approaching 0 like this, I get a very large negative number, right? So when we're doing this fixed over 0, most important thing that we're going to look at is what are the signs of these two things. What's the sign of the numerator? What's the sign of the denominator? We already know that it should get large, because if you have a fixed number on top and the bottom gets smaller, the ratio gets bigger automatically. It's just a question of whether or not it's positive or negative. Is that clear to everyone? Fixed over 0 is infinite. It's just, is it positive or negative? With me? Okay, so here's the way I like to do this. I like to draw a couple little pictures. I like to put the number that I'm approaching right here on the number line. There's 3. Which side are we approaching from? From the right side. And then I like to just take an example of a number that's just to the right of 3. 3.1, 3.01, 3. Right? Anything you want. 3.01. And I ask myself, what would happen if I take that and I plug it in here? So what would the top be?
4 plus 3.01.
So it would be like 7.01. It's getting really close to 7, yes? And the bottom is going to be 3. Take away 3.1. 3.01.
0.1. 0.01, sorry.
Negative, right? It would be negative because I'm doing 3 take away 3.01. I would have a negative 0.01. Do you all follow? Yes? Okay, so remember, fixed over 0, we already know it's going to become infinite. It's a question of which infinity is it, positive or negative. So what do you think? Your top is positive, right? 7, that's a positive number. You're not even close to a negative number, right? On the bottom, it's a very, very small negative number. The ratio of a positive divided by a negative should be negative. And that's all you need. That's it. You're done. Okay? The answer to this is negative infinity. That all right? All right, let's try it the other way. Let's do the same problem. This time let's approach 3 from the other side. Let's do the limit as x approaches 3 from the left this time of 4 plus x over 3 minus x. So you come in, you do the same thing, right? You check on top and bottom. You realize you're going to get 7 on top and 0 on the bottom, and that this is looking like fixed over infinity. Sorry, fixed over 0, which means that it's going to be infinite, probably, right? Just a question of positive or negative. So you draw a little number line. You place your 3 on there. You come in from the left, so you have to think of a number over there.
2.99.
2.99 if you want. Close enough. And then you plug that in. So what's 4 plus 2.99? 6.99? That's close to 7, right? It's headed to 7, getting there. And on the bottom, this is a little different than last time, right? We're going to get what?
0.01.
0.01. Right? Positive this time.
So positive.
Positive over positive is positive. So the answer to this is positive infinity. Good? So does that make a little more sense now on this table? when I have written here fixed, let me see. Do I have fixed positive? Yeah, fixed positive over 0 positive. Do you understand what these little pluses mean now? Was this top one positive or negative? Well, it was what? Positive. And on this one, the bottom was approaching 0, right? This is getting close to 0, but it was a positive number, so that's positive. And therefore, you would get positive infinity. And you see the other 4 different combinations? You could have negative over here, positive here. You could have negative, negative. You could have positive, negative, right? Good? All right, let me ask this then. Same problem. I didn't put the answer. Answer is infinity. All right, let me do this one again. I'm going to take the plus away. What does that mean? You have to check from both sides. And we're going to have a problem. What's the problem? From one side, it's positive infinity, and the other side is negative infinity, and they are not headed to the same place, right? Negative infinity and positive infinity are like completely opposite sides of the spectrum, right? Now they're related in the sense that they're both really big, but one of them is negative and one's positive. Therefore, we cannot say that this limit exists and that it's equal from both sides, so our answer would be does not exist. Does not exist. Yeah?
And that would apply for any problem that doesn't have a plus or minus.
That doesn't have a, no, that's a good question. Very good question, which is going to lead me exactly into my next example. So the question was, if this doesn't have a plus or minus, then automatically it does not exist. No, unfortunately. So let me show you an example of one that would. Okay, so let's go to a different number. Let's go to -5. And let's go to x plus 2. And on the bottom, let's go to x squared minus 10x plus 25. So we're going to check first to see what's happening, right? Check to see what's happening. All right. We plug in direct substitution into this thing. What do we get up top?
3.
-3, right? -3, right? Over, it is 0. Let's see. This is -5 squared is 25. And then, hold on a second. Plus, hold on, make this a plus. We need this to be a plus, pardon me. What would have happened if that was minus, sorry. Whatever answer we got would have been our answer, we would have been done. I don't want that, I want it to be bad. Okay, so 25, and then the other 25 is 50. When I plug -5 in here, I get -50, and so that will be 0, right?
Yeah.
Okay. All right. We have fixed over 0. So that means I need to go try and figure out, right, what's happening. Is it going to be fixed positive over negative, or what's the deal? So I said to draw a number line, right? And to put -5. And which side are we approaching from? Both. So we have to do this as 2 separate problems. We're going to do it here. We're going to approach from the left. And then over here, we'll approach from the right. And let's separate our trains of thought. We have 2 different things we have to do. Understand? All right. Now, what happens if we try and plug in a number to the left of -5? What's a number over here? Careful. 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 What number's over here? 6. And what number's over here? -4. I do this intentionally because this is one of those things that gets people, right? A number to the left of -5 is something like -5.1. And I would have to plug that in, wouldn't I? Right here? And up there? Would we do that? Now, does anyone see anything that we could do right now? Does anyone see the denominator can factor? What is that factor to be? X plus 5 times x plus 5. Same factors, which is the same as x plus 5 squared, isn't it? So watch the way I'm going to write this. I'm going to rewrite this limit, x approaches negative 5, as x plus 2 over x plus 5 squared. That's what it is, right? So if I plug in a number like negative 5.1, what is the top getting really close to? Negative 3.1, something like that on top. Over, the bottom is headed towards, let's see, this is negative 5.1 plus 5 is negative, right? It's negative 0.1? Ah, that's the key. Negative 0.1, but then I square it. That is the key to the problem right there. The fact that that's a squared, does it even matter what this turns out to be inside? It's not going to matter. So we know this is approaching 0, and if you square that number, it's still going to be close to 0, but it's going to be positive. So what we have here is a fixed number on top, which is negative, right? Negative 3.1, over a number that's headed to 0, but it's always positive. And when you have a negative over a positive, your answer would be a negative. So the limit for this one, right, and I should have put right here a little minus sign here, right, because we were coming in from the left. Okay, that this answer is what? Negative infinity. All right, that's only the left limit. Now I have to do the right. Do you see it's not going to matter though? Do you see that even if I plug something over here on, to the right of negative 5, this squaring again is going to always make that denominator positive? But I'm going to do the work. I'm going to show it. So limit x is going to negative 5 from the right this time of x plus 2 over x plus 5 squared. When I do that, and I pick a number like what?
Negative 4.9.
Negative 4.9. And I plug that in, the top is going to be, what, really close to
2.01?
negative? Negative or positive? Negative 2.9 is what the top looks like it's getting close to.
That can't be wrong.
What's that? That's right. It's getting close to negative 3, right? I mean, this was negative. We know the top's going to negative 3. Look, here it was negative 3.1, so it was a little bigger than negative 3, and then here it's a little, I should say it the other way. No, that's right. Okay, over what? What's negative 4.9 plus 5?
0.1.
0.1, right? Positive, but who cares? I'm squaring it. And so we're still going to get what on top? Fixed negative over something that's headed to 0, but it's positive.
Still negative infinity.
Still negative over positive, which means that this limit is negative infinity. So the left limit and the right limit are the same, aren't they? And so your answer is negative infinity. Yes?
So in the instance that they don't match up, it just says
Does not exist.
Okay.
Yep. And whenever you have these infinite answers, right? In the course video, I said that would mean that if you look at the graph of this and you go to negative 5 on its graph, what do you have happening here? A vertical asymptote.
But they both go.
In this particular case, we would have them both sides diving down, is what's happening here. In the last case, it was opposite.
And that would be the does not exist if they're opposite, right?
That's right, if they're opposite. Yep. All right. try this. Limit x approaches -2 of x minus 4 of -2 from the right side of x minus 4 over x times x plus 2.
They're still in infinite limits, right?
Yes. Where's the top going? -6 over, see, this is -2, right? That's headed to -2 times 0. Agreed? Now that still is fixed over 0 because -2 times 0, that's still going to be 0. So this is still fixed over 0. It's just a matter now of determining whether or not we have, you know, positive or negative. Now you can tell right now what the top's going to be, right? The top is negative, but you have to be careful because we also have a negative down here. And these two negatives together would turn out to be positive. So you don't want to just look automatically at the top and say, oh yeah, that's negative. Just go through, draw your number line, take your time. -2 is here. Pick something from the right side, which means from that direction. So what do we have there? -1.999? Something like that? -1.99. Let's use that one. Now let's go ahead and just kind of plug them in here. What would we have? -5.99 on top. Do we agree? No? I'm doing -1.99 minus 4, so it would keep. We're good? Bottom left corner would be what? -1.99, something like that, times what? -1.99 plus 2. Positive 0.01. All right. What's the numerator going to be? We have a fixed negative number. What about the denominator? It's headed towards 0, right? We already knew that. But it's headed to 0 through negative numbers. Okay, because look, this is negative, right?
Yeah.
And that's positive. And a negative times a positive would be negative. Yeah?
I got it. It's 0.0199.
Yes, and it's negative though, right? So
Still
negative, negative, positive. So the limit is infinity. So if I were to graph this function, if I were to graph it, and here's -2, and I start graphing it from this direction, I know it's going to head up like this, right? Vertical asymptote right there. Now what about the other direction? You'd have to take the limit from the other side. And that's not what you're being asked. So look, if you want another, I mean the summary on the sheet is nice, but I like to also throw one more thing in here just so you're clear. If you ever have fixed over 0, all right, anytime you have this, there's 3 possible outcomes. What are they? Infinity, negative infinity, or does not exist. That's it. That's all you're ever going to get. That's it. Okay? Now you have to go do a little work to figure these out. And a lot of students have trouble, like they're like, well, what do I show you on the test? You know, like what's my work? Basically what I just have been doing is your work. That's what you have to do. You don't just type it into the calculator and graph it and look at the asymptote. That won't get you any credit, right? I need to see that you know how to analyze a limit without the graph. And you might ask why, right? Why? Because there are functions that if you look at the graphs, your computer will fail you, and what you see is not what's happening. Computers have limitations, all right? So we need to have a way of doing this algebraically that we can be confident with. And plus, this is all just about like number sense, just understanding how functions behave and how numbers work. All right, let's you try one. We'll do a little class activity here. Why don't you see if you can do this? The limit as x approaches -2 from the left of x cubed minus 5x squared plus 6x all over x to the 4th minus 4x squared. Enjoy. I'll give you some time to mess with that.
4x.
Hmm?
And I'm on
You?
I'm on the way. It helps.
Okay, yeah, that's fine. And if you're getting hung up, your neighbor might be able to help you. If you need help, just raise your hand. I'll come by and nudge you in the right direction. If you get an answer, let me know. Let me see what you did. So what did you do? Factor the time out?
Oh yeah, and then I canceled those two. I got this, and I just went down and started breaking it down. First I got 10 over 0, and then
You
I
checked
did
your direction.
negative 2.1.
Uh-huh.
And then that was the first line you don't really
So,
have
I
to
mean,
do.
based off of that,
The what?
The top line you really don't have to do, because I've never...
Yeah, you kind of know what it's going to be from the very beginning. No, it won't.
Okay, so it's...
Yeah.
I mean, now we do the bottom line, negative.
That looks right. You stuck or are you good?
I'll just let you check it.
I got infinity in my answer.
Let me see.
Because I got a negative 2.01.
So you have negative on the top?
Yeah.
Let's see. You're headed to -2 on the top. Let me see. Let me check yours too, also. Y'all got very similar answers, but they're different.
Okay.
I'll come back and verify. I need to look at enough people. You got a positive infinity?
Positive infinity because I distributed the x square around the x x form of minus where since it's a limit coming from the left, so I had to put the distributor from to -2.01 and multiply it into the x's. And I got positive. Both of them come out positive.
All right, I'll check. I'm seeing what other people are getting here. Negative. Okay, so we have 2 positive infinities and 2 negative infinities right now.
I got a
Negative 3 negative infinities, 2 positive infinities. Yes. And cancel, and yeah, you could mess with it. Oh yeah. Yep. See, what is that? 3 minus 3. Wait a minute. Hold on. Minus 3 minus 3.
But I mean, I guess
All right, I've put the work up here. Factor out an x on the top, factor out an x squared on the bottom. I still have no idea what this thing does because I personally did not feel like plugging -2 into this. It looked like too much of a mess. So I tried to clean it up first. And when I got this trinomial, I factored it. And then difference of squares, I factored it. And then I noticed I had a common factor of x minus 2, so I can cancel those. As long as I promise you I'm not headed towards what? 2. I'm not even close to 2. I'm way over here at -2, right? So I don't worry about the canceling. And then I cancel one of the x's as long as I promise you that x isn't 0. But x isn't 0. I'm headed towards -2. So I can do that canceling. Here's what I have left. If I plug in -2 up top, I get -5. -2 bottom left corner here. -2 in here, I get 0. So now I know I have fixed over 0. And so now I'm just going to draw a quick little number line. Here's -2. I'm going to approach it from the left. So a number here, -2.1. And then just plug that in real quick. The top is going to head to -5.1, and the bottom's going to head to, don't forget this one, -2.1 times -0.1. So you get a negative on top, and negative times negative is positive. So you get the ratio of a negative over a positive. So this is negative infinity. Question?
on the test, are you going to want us to factor it all out?
What I don't want to see is a student just pick a number like this and just plug it into everything. Okay? I want you to identify where the issue lies.
Okay.
All right? Now, yes.
So I did the same thing, but I forgot to cancel out the x.
It's okay. It wouldn't have affected it. You would get the same answer.
I got positive
Yeah.
on top and negative.
Yeah.
I forgot to.
That's okay. You'll get the same thing. Yep.
I forgot to distribute out the x from the 3 cube and
X cubed part.
x cubed part. Yeah. Next thing you know, I did distribute the x.
So if we guess and get it right, does it count?
If you guess, Well, it can either be infinity, negative infinity, or it does not exist, right? So if you can, I will allow you to guess and get it right if you use a three-sided coin. So that way you can show me you're flipping your three-sided coin. All right? So bring that into the test.
1D3.
All right, how about this? You sound thrilled.
We just like killed everything. Just when we start getting it.
So you see this problem, and it should look familiar to you. Like we've seen that in the last section where you had where we had to peel everything apart. Remember that? We do that when we have 0 over 0. You do not have 0 over 0. So don't start peeling this apart. Right? Let theta go to 0. Let's approach this left or right. Right? Okay, from the right plus. All right. So let's try this. If we do 0 in here, 2 times 0 is 0. Cosine of 0 is 1. Okay, good. And we have 1 on top, and on the bottom, sine of 0 is 0. So we have fixed over 0. So we just need to figure out if it's infinity, negative infinity, or does not exist. That's it. So no peeling apart. It would only be if we would peel it apart if this was what? 0 over 0. All right, so I just need to determine the signs. And so I'm going to be approaching 0 from the right side. And so I could pick a number, right? And start plugging it in, but I'm going to plug that in here and here, right? Yeah. I'm going to try and do this without a calculator. So let's think about this for a moment. Let's think about this numerator. See how even if I picked a number like 0.01, I would still have to plug it in here, double it, and then do cosine on my calculator to figure out what the answer is, right? Theoretically, that's what I will do. If those were just like, theta squared plus theta and there was no cosine, then it would be easy to just look at it and see maybe. So what I'm going to do is I'm going to look at the graph of cosine 2 theta, because I took pre-cal, and I remember that we did this. We know that cosine function looks like this. That's from 0 to 2 pi. That's cosine theta, right? Not 2 theta, that's cosine theta. What does cosine 2 theta do? It does something to it. I'm not gonna, yes, the period's changed. Instead of it covering an entire cycle in 2 pi, it's actually going to do it in pi, exactly, half of that. So I don't know if you remember, but the number in front of theta, you take 2 pi, this was the formula, 2 pi over b. B is the number in front of theta, or the number in front of x if this was cosine x. Divide 2 pi by b, and that's your new period. Yeah, that was pre-cal, a long time ago. But look, if I draw that in here, so it's this blue one, it's going to basically do the same thing in half the time. What I want to know is what this thing is approaching, right? What is this thing approaching? Is I approach theta from the right of 0. So just go to this blue curve. Here's 0, right? Walk along this blue curve on the right side of 0 and start approaching. And where are you headed? 1. You're headed to 1, aren't you? You're headed to 1, which is kind of what we knew already, right? We knew that. So the top is headed to 1, which of course is a positive number. I'm just going to put a little plus there just so we all agree it's positive. Now what about sine of 4x? What does that look like? Well, it starts at the origin, it goes like this. That's the normal sine function, but with 4 theta, it's going to go, compress it down, and it's going to do an entire cycle, not in half the time, but in a quarter of the time. So it's going to do like this, all the way down and back up, right? Something like that. And what I want to do is approach 0 from the right. So walk along this curve right here from the right side of 0 and start walking towards there. Wouldn't you go up first, and then you come back down, and you're approaching 0, aren't you? But are you positive or negative as you approach? You're positive because you're above the x-axis. So you're approaching 0 here through positive numbers. See, I didn't need a calculator for that. Now I needed to know how, well, did I even need to know that this was compressed? Not really. It still came in like that from the top. Both of these do that. With me? What's my answer? Positive infinity. Okay. There will be more examples in the homework for you to work through, and have fun with that. We're moving on. Now we're going to do limits at infinity. And this is where we have something like what I said earlier. We're going to let the x approach positive or negative infinity. And then here we're going to have a function. And that's what makes it a limit at infinity. So let's do an example. Oh, in the notes, what I asked you to know today, which was on the quiz, please note that the limit as x goes to infinity of 1 over x to the n equals 0. And I want to extend on this even further, something even more general than this. Generally, if you take a limit, and it does not matter, okay, does not matter, of some function, and what you get is fixed over infinity, not fixed over 0. Fixed over infinity, the answer is 0, and that's on your sheet. And just think about this for a minute. If you have a number that's not moving, it's just staying there, and you have the denominator is getting huge, that ratio should get small, right? 1 over 10, 1 over 100, 1 over 1,000, 1 over a million. It's getting smaller and smaller. Yes?
What if, oh wait, no, never mind, that's the question. It works, never mind.
Good? Okay. So anytime we see a fixed number over infinity, we're done. We're done. We're done. It's 0. Got it? This is kind of like one example. Look, if x gets big, right? X gets big, and this n here is either a 1 or a 2 or a 3, then what you're doing is you're saying let x get really big, and then what? Square it? That's even bigger. So you have a fixed number over a huge number, that goes to 0. Yes?
Can I ask you a question?
Yes.
What if n is a negative?
Then that wouldn't work.
It wouldn't equal 0?
It would not equal 0.
Okay, and then also on the bottom where you said fixed, what if there was a variable up there?
Then it wouldn't be fixed, and we would have to look a little harder.
Okay. So say it was like x plus 2 over infinity, for example.
Well, it wouldn't be x plus 2 over infinity. It would have to be x plus 2 over something with x in it also.
So the book will never give us one of those?
Yes, you will.
Of x plus 2 over infinity? Or will it?
Well, it'll be x plus 2 over, say, like x squared minus 10.
Okay.
And so you've got x's on the top and the bottom, and they're both going to infinity.
Okay.
That's our goal, okay?
So give us a variable over infinity.
Yes, you will have variable over variable, and they'll both go to infinity. That's kind of the goal of today, like this second part. But before I can start, we need to all agree that if we do have a number stuck on top that's not changing, and the bottom gets huge, that then goes to 0. Can we all agree on that? We understand the idea of that ratio smashing down to nothing? Okay. From that, we should be able to do everything else. All right, so let's take a look at our first example. This one will be pretty straightforward. Limit x goes to infinity of 5 plus 1 over x minus 10 over x squared plus 1. So this is a limit at infinity. meaning that the x here is headed towards not a fixed number, but infinity. So x is getting huge. How does this limit affect 5? It doesn't, right? It doesn't. Now what about this part right here?
It does.
What is that? What happens there? That goes to 0 because it's fixed, right? On top it's a 1, and on the bottom it's x, but x is getting infinite. So that's going to get smaller and smaller and smaller the further we go. So that should go to 0, right? That should, we say that term vanishes. It goes away, all right? That's going to go to 0. And then what about this one right here? You get 10 on top, which is fixed, right? And then on the bottom, infinity squared should be huge, right? Plus 1, it's still huge, right? What's infinity plus 1? Infinity still, okay? That's kind of an interesting fact about infinity. Infinity plus 1 is still infinity, all right? Infinity squared is still infinity, all right?
It's more than infinity though.
Well, but you can't, yeah, it's a weird thing. All right, so we still have fixed over infinity here. So that one's going to go to 0 when we take the limit, right? When we take the limit, it's going to go to 0. And that means the only thing left is what? 5. So this thing should be heading to 5. Right? So if I just start picking some numbers for x, like if I plug in 1 here and 1 here, I'm going to get an answer. Now if I pick a bigger number for x, like 10, plug them in, I get a different answer. If I plug in 100 for x, I get a different answer. The further out I go, the closer and closer I should get to 5. Doesn't mean I'm ever going to get there, but I should get closer to it. Now that one was pretty straightforward, right? Not a lot going on there. Turn the screws, thank you. All right, I like that. This is infinity over infinity. This is not fixed over infinity anymore, because the top here, 4 times infinity should still be infinite. So we've got this form now. We've got infinity on top, and on the bottom 20 times infinity is still infinite, plus 1 still infinite. We got infinity over infinity. This is bad. Okay, this is bad. This is just like 0 over 0 was. And this is not like what we just saw a second ago, where there were like 3 possibilities, remember? Like fixed over 0, 3 possibilities. Infinity, negative infinity does not exist, and we just went and figured it out. Here, this is bad. It's in a different part of your table. It's in the top left part of the table, which means we need some algebra or some trick, right? So here's the standard protocol for this. You ready? You're going to try and use this stuff to solve this. You're going to try and create fixed over infinities. And the way to do that is to look at what you have, take a look at the denominator, all right? Take a look at the denominator, and take a look at your highest power of x. See it? X to the first power. You're going to try and eliminate that x. So to get rid of this x, I would have to divide this term by x, wouldn't I? Divide it by x. So I'm going to introduce a very special 1 out here. And the one I'm going to introduce is 1 over x times 1 over x. Now, you'll see why this works in a second. I said algebra. I said you have to use algebra or some trick, right? This is algebra, but it's just kind of tricky that, you know, I'm doing this. Let's see the net effect of me doing that. First of all, what happens when I multiply this 1 over x across the numerator? You just get 4. Does everyone understand that I am not changing the problem? When I multiply by 1, this is a 1, that I'm not changing the problem. I'm just changing the way it looks. So I get a 4 on top. Pass the 1 over x through the bottom. What do you get? 20, this is 20x, and then this is over x, right? Because that x is going to go underneath. So just 20 plus, now you have to